Real-time feedback into the behavior of your distributed systems and observing changes, exceptions, errors in real time allows you to not only experiment with confidence, but respond instantly to get things working again.
Hello everybody, my name is Anton Kalik. I'm software engineer from amenities.com, and today I'd like to present my topic about translator words application on JavaScript. Literally is the story of creating from scratch startup till the workable end solution. We're going to talk about what kind of tools it's necessary to have in order to bring up the startup with a potential scalability for the future. We check the corner cases and what kind of tool better to use in scope of JavaScript for sure, and we gonna check the details of the schemas, how to connect, communicate, and make alive your startup idea. And the example of that, I choose that project which has been created actually by my brother, and I was involved with to set up the service for that, and client side for desktop, and here the mostly a story of creation of that project, where we were started, where are we right now, and all of that development details, which could be interesting for you. So let's first of all, let's take a look on what is the project is that. So my brother created that word deposit iOS application, and I was thinking with him just to improve the project itself, to bring this more scalable for the future, which database to use, which service we're gonna use, and how we're gonna use the clients in our case, and so on. So server and client. This is the crucial communication between that and what I decided to choose. I decided to choose Node on the server side and React on the client side. Definitely my tool is JavaScript, and that's why I decided to go in that way. And where to start? So this is actually a very important question, because firstly, I was thinking, okay, I need to create something like a logic algorithm to check it up, like how it could work, and up front of that algorithm to build the project. So what I mean by the logical algorithm, it means like the basic solution of the problem solving, and then according to that simple small problem solving solution, to have a scalability architecture. Okay, so from the small one solution to the scalable architecture. And let's go to the very basic one, schema, how I was thinking, how we can spread out the project. And I was thinking like, okay, we have to create a database, whatever it is, Postgres, Mongo, or something else. We communicate with database through the server, and brings the data right to the client desktop and client mobile. Well, eventually the tools is for database was MongoDB, server created by solid.js together with GraphQL, which I will show more expanded schema lately. But the most important instruments over here: Mongo, Node, React. And some of the clients could be on React Native or iOS or whatever it is. How to store and serve the servers, because all of this could be have to communicate between each other. I chose Amazon Web Services instances. I split 3 instances between client, server, and database, and this is the communication. So for the React Native or for the any other phone applications, it could be a Apple or Android development platform, which is fine. So, but today we're gonna talk mostly about the database, server, and client on React, and all of them was an instance Amazon Web Services, and communication between them through the routine 53 from inside the Amazon. There is a couple of rules between connections, the security part, and Nginx and Nginx setups. I will show you lightly. So for now, let's take a look on the Node.js server, what we have over here. As I said, we have a database, MongoDB, and Mongoose ODM actually communicate with database through the models, and models and Apollo server applies those models and communicate with the models through the resolvers. And resolvers could be mutations, queries. In some cases, it could be subscriptions, and it's like a structure of communication and manipulation with your database. So Apollo server applied that the resolvers, which is mutations and queries, and comes right to the Apollo. And there is the flow of communication, and all of structured data which is going to the client, to the clients, has to be alignable for the GraphQL schema, and everything spinning around from the core server. So launch it on the core server, and that's how we are providing our data for the clients. Docker for sure. Locally, you can use Mongo. You can use for the Docker. Just to use the Docker Compose app to build Mongo and connect to the database. Let's take a look on the initial setup of the core server. I choose core for the Node server. You can choose Express and whatever you want, but in this case we consider that framework core. So from core I created the application itself, instance of database, and connected to database. Couple of the middlewares, for example, there was one of the interesting GraphQL upload core, which is handling the uploading of files, listeners, and open the port for our server. So, but it's not that's it. Actually, we have to set up a Apollo server, and in the same way, we just starting our Apollo server with applied middleware for specific path. We're gonna listening API v1 GraphQL in order to have our request against server. Yes. So, what is the Apollo server setups over here? So this is pretty the same, like it's prescribed in documents and so on. I just brings for this session the whole amount of work what has been done in order to have a skeleton of building your startup solutions where we included GraphQL and Apollo server. So here you can see that we using the make executable schema, which is getting the type defs, which is schema GraphQL itself. Resolvers, as I showed it in the schema. Let's see, back to the schema. You can see that Apollo communicate with resolvers. So we're catching the errors and formatting the errors, and also the context. So context, checking the token from the context arrived right from the core. We are getting that token from authorization header. Validate that token. By validation, we will understand this is there a session or not. So if you have session, we provide that session passing through the context, or session could be a null if there is no if validation has been failed. Where to go that context? Right to our resolvers, where we can reuse our session and asking data from the session like email, ID, or whatever it is. So let's back a little bit to the database layer, and let's just take a look how we communicate with database. So we have for sure some of models. In my case, well, the models of words, stacks, collections, and related to and of course user. So just a couple of models over here that, for example, word schema, which is have a unique ID, creation date for sure, and translations, which has to be from to, like language is a code of the language and value of the word itself. As I said, that a multi-language, that means it could be different languages, and word has to belong to the specific stack where we're training our words, which has been created by the user, and for sure author who was created that stack and that word. So how looks like the stack schema? It's UID, of course, title, possibly subtitle, date creation, and stack can consist some bunch of words, and of course it's that model belongs to the author, that the user who created that stack. So resolvers, as I said, those models comes right to the resolvers where we can reuse those models and communicate with database. In this case, for example, we are taking the model of word, trying to find by specific parameters the specific word, specific words, count them, trying to find the real items, sorting them, and passing to the specific function. And just to let you know that resolvers always returning some information, always the queries and mutation according schema, what you describe it in your GraphQL schema. So cursor output will brings the object structured exactly how it's described in a GraphQL schema. This is the pagination part, cursor output. So this is what we're expecting in the end from that get words by stack ID. Mutation is the same thing. We are asking just the context where are we expecting to get a model, because remember we're passing to the context all of our models. If we just back here, you can see models always on the returning from the context. So that's why we got that model over here, and access to the session. User has been found, for example, here from the session ID, because we can find that user by session ID if it exists there, and user made some update because of mutation. Mutations is something what we updating, what we posting to our database query is actually what we're getting from our database. And for sure, in the end of the process of mutation, we are returning some get statistic stuff over here. You can see that we using get statistic really literally right from the query, because if we go to the get statistic, we're gonna see that a bunch of additional queries where we in the end from the promise returning some structured data exactly for the for GraphQL schema. How looks like the GraphQL schema? I think for most of you it's pretty familiar. It's just types where we describe it, our queries, mutations, as I said before. Subscriptions could be possible as well. And types of the what we're expecting from our queries or mutations. Let's say like we have a get stacks, we're expecting stacks type, or let's say when we are update user on a mutation, we're expecting to receive updated user with updated information. So, and type user describe all of the fields what we are need. The exclamation mark here, the mandatory fields, we should receive always that type from that field. So execute schema with resolvers. Actually, that what I told before, that makes us possible to communicate with GraphQL from the client side, and to use queries mutation on the client side. And we are using this GraphQL schema mutations or queries, and we're using on the client side. So time, I think, to go to the client, and as I said before, locally, for now, we're gonna use that local host, the API v1 GraphQL, what I told before, when the initial entry point to the server where we started our Apollo server, we put the path API v1 GraphQL. So API v1 GraphQL could be not from under local host. It could be a different Amazon Web Services through the router. You can provide everything you want, especially with the specific authorization part and security layer. So now we're just talking about locally connection, and let's take on the React client now. As I said, the Node.js server provide to us through the local host, through the route API v1 GraphQL, the possible of the connection to the data for the GraphQL. React client making this request to the Node.js server and exposing to the browser. Locally, it's a localhost 3000, but you're gonna build your files and going to use your build files on other services through Nginx part. In my case, as I told before, it's Amazon instance. So let's dive into the React client. For sure, it's bare schema where what I'm using in the application mostly. If I creating another application, another service on the client side, mostly I'm using the same structure. Application applies the Apollo provider, which is Apollo client. What is the Apollo what we passing to the Apollo provider? Queries, mutations, and fragments. Fragments spreadly using by mutations and queries, and Apollo using the Apollo client, and the providers comes right to the application. Also state management, which can be created by Redux or whatever you want, but I using context with read user, with actions, dispatchers, and I have a initial store just to have everything in box. But of course, you can say that we can reuse power of Apollo client, because there could be some kind of Apollo state, or we can reuse some other approaches to have global state management. In my case, I'm usually trying to split it up between in the entities like context with the state management, Apollo with queries mutations, styled components. It's just a feature for the styling of your components and views and other things. For example, global styling. Of course, components itself and views. Okay, so everything, all of these parts, all of application, in the end goes right to the DOM system. Okay, so how looks like the providers itself? So I instruct the application. First, I provide the Apollo provider to the Apollo client. How looks like Apollo client I will show you later. But then I just go into the context provider, which is session, which is a state manager, and then theme provider if we have something like a dark theme or day theme, whatever it is, and global styles for sure. So some generic styles. Theme provider, global styles comes from the styled component. Context provider, we are using the powerful of React itself, and Apollo provider comes from the Apollo client. Well, Apollo client is that how we are connecting to the our server through the great HTTP link. We just put there that exactly that path what I told before on the server side, that we opened that API with our GraphQL. That's how we are connecting to the HTTP link. For sure, you have to have a proxy for that with the specific and for the local host and for the production one. So Apollo, before creating the Apollo client, you have to bind different links. The first link you can see HTTP link, which is connection one, error link, which is handling the errors and exposing some specific error from GraphQL errors or some other errors, forwarding the operation itself. Then we are creating auth link, which is using headers in order to provide a token to the headers, which is authorization, and cache. In the end, we are caching our pagination part. In my case, I just using the fields, get stacks or get all words. When you're scrolling, you can fetch more data, like list of the data. In my case, it was in translation application, it was list of words, and you can scroll and you can get the pagination. That relay style pagination provides right from Apollo client. And once again, all of tools, what I described it here, it's like no more, no less, exactly that amount of tools, that functions, that features I'm using exactly in scope of that tools. So, and in the end, Apollo client with all of the links, error link, auth, HTTP link, and cache itself, that's how we are creating Apollo client, and we providing right to the, before showed you, right to the Apollo provider and Apollo client over here, okay? Well, context provider, as I said before, the context manager. Here also, there is no any specific good approach, like good practice or something. This is just a bare minimum to have your project up. And here for example, this is the state management where we are creating the context provider. I just getting the child, provide to the child that provider with the store and dispatch for the actions, and I creating the user, creating the reducer with the initial state for sure. And across my application, I have access to global state management. Whatever I have to save there, I have the next over there. To have a scalability and to not have everything in disorder. Nice to struct all of your components, views in the same structure, like to have a rule. I want to show my own personal rule how to struct independent components, atomic components, which you can use across the all application on the React applications. For example, let's say we have button. Okay, so always the folder button from the capital letter consists index.js file with the implementation itself in the code, button.test, where we are having our unit test for the button, and styles, which is styled component. And you can see that views and components, they are different. Like they different folders in the source folder, where we have the full of list of our components with all the time the same structure. Index, the component name itself .test, stylus. All of them have the same structure. Okay, and the views the same. Literally views the same component, but logically views it's related what we are showing in the router. How it looks like inside the component in implementation is just like a input with the styled containers, styled elements with passing props, and we are reacting on that props. So there is no any tricks. We're just using the component and style that component, and for sure in the same folder has to be a unit test. Okay, let's back to the GraphQL, to the Apollo client side, and we can see that user fragment here, it's just the same list of fields what we have seen in the GraphQL schema. So here the necessary fields to us on the client side, which we can reuse as a fragment across all of our mutations and queries in Apollo client. And for example, as you know, Apollo client has the specific hook for the query use query. We have to provide that query, for example, over here is a get session where we're using our fragment. That fragment has been created over here. We just reusing over here that fragment, and that's how we are can reuse that fragment across the other requests, other queries. Or when we don't need at all any fragments, we just can use the plain fields. In this case, we have a mutation for sign up user, and we are expecting just to return the token, which we're going to use lately for header and UID, of course. Well, also about the fragments, you can fragments created exactly from the type. So we have type user, we can create the fragment of the of that type. We have type of word, we can create the fragment of the word and reuse from there some fields. So in general, what to take to the application? This is actually a very controversial question on the beginning when you want to bring up very fast your startup and which tools to use. I suggest in this case, in terms of JavaScript, who are using JavaScript, to use the tools which is really familiar and very and kind of famous and successful tools for now, like a GraphQL, styled components are using everybody. Amazon Web Services for sure now. It's a really big benefit to serving your data services, databases. Database, for example, MongoDB, because it's just very easy and very fast to build up your application over there. So also, as I told before, though, very important to keep good structure in your applications in the folders of your components, views, or in your resolvers on the server side, to split up like between this is mutations, this is resolvers, and where's utilities and so on. So to keep everything in order, and it's as I say, what to take in and where to start and how to keep it in order. That's the approach, like to have good folder structure in your applications. And in the end, this is the full of the tools what I'm using for the service. It's a JOT token, GraphQL, Apollo server, which is works to us for the communication with GraphQL client, which is communicate with the GraphQL through the server. So and all of these tools actually, this is enough. It's to create the application till the end workable solution on the production side. It doesn't matter what you're going to choose. For example, you can choose the Amazon Web Services instance, or it's going to be another service, Heroku, for example. Maybe you're going to use the Postgres, but like Postgres, you have to use some kind of ORM system in order to communicate with the Postgres. Almost the same, like more or less the same. It's going to be not just another database. Couple of tools what I'm using here, for example, why I'm using Core, because it's my opinion just a bit easier and much faster than Express, and consequences of middleware stays are really straightforward for me. Hosting, it's just up to you. Not Mailer, for example, I'm using for the handling emails, to send some emails from my server. For example, forgot password or whatever it is, just send email. For sure, in future you can increase and you reuse some of services for the emails. It's just a bare beginning of the application for the startup. PM2, for example, this is just a tool when you have keep running your server on instance on a production without stop. So Circle CI for deployment process, Jest for unit tests. For sure, passively together with Jest, you need to have additional tools for the React, for example, testing library or enzyme. So that's up to you, but mostly it's everything. It's unit tested. Jest tests very important in the beginning as well. So you for the validation of fields. Yes, and the price is actually for the starting around $65-70 per month. So, and I think for the beginning of the application, when you create some workable solution, it's not a big deal, but it's more or less that price for the month. So I would like to say thank you so much for the listening. I hope that information will help and inspire you to bring your ideas alive. I could say that my solution for the service and client side took around 3 months. So thank you so much, and have you seen that in another session. Bye.